the manufacturer produce in a day to maximize his profit? So maximize his profit, this data is already given. That means from this data it is very clear that this will be a maximization problem. But sometimes it is not explicitly mentioned in the problem that it is a maximization problem. So remember that if any data related to profit or benefit is given, that should be a maximization problem. And if any data related to cost or loss is given, that should be a minimization problem. So here clearly we have a maximization problem. Okay, so formulate the LPP, formulate an LPP, do not solve. So do not solve I have written here. That means we only have to formulate. Right now we are concerned about formulation of an LPP only. We will not consider solving. Okay, we will in some later lecture I will cover that topic, how to solve an LPP. So we will only formulate an LPP like this standard form. Okay. Okay, so first, what is the first step? We have read the problem very carefully. Now we have to identify what is the key decision that you have to make. See, if you see this line, you can easily identify, the key decision that you have to make. How many units of each model should the manufacturer produce in a day? This is your key decision. Okay, so you have two models. First, you have an ordinary model, you have an deluxe model. Okay, so these two types of model you have, the manufacturer has. Now, how many units of each model should the manufacturer produce? Now, this is the key decision you have to make. How many units of each model, how many units of deluxe and how many units of ordinary model that the manufacturer has to produce in a day. So you have to determine your decision variable from this only. So we will first assume that the manufacturer produces x1 units of deluxe model and x2 units of ordinary model in a day. See, we have taken two decision variables because here you have two models. So how many of each model you have to manufacture, that you need to determine. So you don't know how many units. Okay, so you have taken a decision variable. Why we need two decision variables here? Because you have two models. If you had three models, say, you would have taken three decision variables. So for deluxe model, you have x1 units of deluxe model you produce, and you produce x2 unit of ordinary model. So this is our assumption. So write down these assumptions, that let the number of deluxe model produced in a day, number or units produced in a day equals to x1, and let the number of ordinary model produced in a day equals to x2. Okay, so this is the decision you have to make, and we have taken two decision variable for that decision. See, this is how we determine the decision variable from the information given. Okay, so x1 units of deluxe model you are producing, x2 units of ordinary model that you are producing. Now we have to formulate. So this is your decision part. This is your decision part, right? So now let's come to the objective part. Now we have to formulate the objective function. An objective function is a linear function of the decision variables. Okay, from where you have to find the objective? See, read the information carefully which is related to the profit, because here we have the profit related information. So read this one very carefully. The manufacturer's profit from a deluxe model is rupees 10. So from one deluxe model he is earning rupees 10. So how many deluxe model he is producing? X1. So how many total profit would he earn? 10x1. From one deluxe model he is earning rupees 10. From a deluxe model is rupees 10. Profit from a deluxe model is rupees 10. So our assumption is we are producing x1 number of x1 units for the deluxe model. So what is the total profit earned by the manufacturer? 10x1. 10x1. So let me write it here. 10x1 is the total profit earned from a deluxe model. Now can you say what is the total profit that would be earned from an ordinary model? See in the next information that from an ordinary model is rupees 8. That means from an one ordinary model you are earning a profit of rupees 8. Okay, so we are producing x2 units of ordinary model. So what is the total profit earned from an ordinary model? 8x2. Okay, so from one unit you are earning rupees 10 from a deluxe model. From x1 unit you will earn 10x1, and from one unit of ordinary model you are earning rupees 8. So from x2 unit of ordinary model you will earn 8x2. So what is the total profit from for the manufacturer in a day? It will be from the total profit earned from ordinary deluxe model plus the total profit earned from ordinary model. Okay, so that is the total profit for a day. So the total profit for a day will be 10x1 plus 8x2. Okay, now how the objective function will be written? This is a maximization problem. So we will write maximize z equals to what? This is the total profit. So you have to, this is the total profit you have to, this is the total profit that you are earning. But as you don't know the values for x1 and x2, so you have to maximize this, you have to optimize this. So you have to write maximize z equals to 10x1 plus 8x2. Okay, so this is how we formulate an objective function, right? Now remember this, an objective function should be an equality, because you have to determine the total amount of profit in case of a maximization problem, or you have to determine the total amount of cost or loss in case of a minimization problem. Here you have the maximization problem, so we have calculated the total profit from the ordinary model and the deluxe model collectively, and this is the profit amount. But this is not an exact amount, as you don't know the values for x1 and x2. In reality you have multiple values for x1 and x2. Okay, you have multiple options for the values of x1 and x2 for the numbers of deluxe model and ordinary model, but you will choose that x1, that pair of x1 and x2 which will give you the maximum value for z. Okay, we will see that, we will see while solving an LPP. So here we are only formulating, that means we are not solving for x1 and x2. Actually we are only formulating, that means we are only giving a problem, a standard mathematical model. We are not solving it, we are not solving for x1 and x2. So x1 and x2 will remain as it is in the problem. Okay, so we are not solving, we are only formulating here. When we will be solving an LPP problem, we will see that how to solve for x1 and x2. We can have multiple pair of values for x1 and x2. We will choose that value which will give the maximum value for z in case of a maximization problem, and in case of a minimization problem we will choose that pair of values for x1 and x2 which will give the minimum value for z. Okay, we will see that. Now, now the objective function is formulated. We know that your objective is always subject to some constraints. Now try to identify the constraints. While reading the problem, we already could identify the problem. I mean the constraints. Yeah, you have 5 skilled men and 10 semi-skilled men. Constraint: no man can work more than 8 hours per day. A constraint. Now see, you have, now let me write down for your simplicity. You have skilled men, you have semi-skilled men. Okay, so how much, what is the amount of skilled men you have? 5. You have 5 skilled men and 10 semi-skilled men. Okay, now if we consider this fact that no man can work more than 8 hours per day, can you tell me what is the total amount of time that can be given by a skilled man? You have 5 skilled men. Each man will work for 8 hours, not more than 8 hours. That means maximum he or she can work for, 8 hours. Okay, so you have, for skilled men, what is the total man hour that you are getting? Man hour means that the amount of time that is worked by a man. Okay, so you have 5 skilled men. Each skilled man will work for 8 hours. So what is the total amount of hour available in a day for a skilled man? It is 5 into 8, 40 hours. So for a skilled man, you have 5 skilled men, and a skilled man can work, all the men can work for 8 hours. So 5 skilled men, all of them are working for 8 hours. So you have 40 hours, effective hours. So you cannot go beyond that. So that is a restriction, that is a constraint. Okay, so for a skilled man, in a particular day, you have maximum of 40 hours. Okay, so similarly, for a semi-skilled man, what is the man hour that you are getting? 10 semi-skilled man you have. Each man will work for 8 hours. Okay, so you have 10 into 8, 80 hours. So for a skilled man, for skilled men, you have 40 hours available time. So you have to, you can work, make them work for 40 hours only. So for one skilled man, you have 8 hours. So for 5 skilled men, you have 40 hours. So for one semi-skilled man, you have 8 hours. So for all the men, it is 8 hours as given in the problem. So you have 8 hours for a semi-skilled man also, and you have 10 semi-skilled men. So you have 80 hours. Okay, so this is the total hour that you have. Now for manufacturing the deluxe model and ordinary model, what is the amount of time required? That is your concern. So read the problem carefully again. So for a deluxe model, what is the requirement, and for an ordinary model, what is the requirement that you have to determine? Okay, so if you read the problem carefully, then you can see that making of a deluxe model requires 2 hours work by a skilled man and 2 hours work by a semi-skilled man. So for making 1 unit of a deluxe model, you need 2 hours work by a skilled man and 2 hours work by a semi-skilled man. Okay, and for the ordinary model, for 1 unit of ordinary model, it requires 1 hour work by a skilled man and 3 hours work by a semi-skilled man. Okay, now think like this: what is the total amount of time required for making 1 unit of deluxe model and ordinary model? What is the, first consider the skilled man. first consider the skilled man. For what is the total amount of time required for by that means given by a skilled man, that should be given by a skilled man to make deluxe model and ordinary model. What is the amount of time? So we are only considering skilled men for the first time. Okay, so making a deluxe model requires 2 hours work by a skilled man. So one deluxe model requires 2 hours work by a skilled man. So what is the number of unit that we are producing? Deluxe model x1 units. So for 1 unit of deluxe model you need 2 hours work by a skilled man. So for x1 unit, what is the total hour that you will need for a deluxe model for a skilled man? It's 2x1. Okay, so for producing one deluxe model 2 hours work by a skilled man is required. One deluxe model. So for x1 number of deluxe model, that was our assumption, x1 unit we are producing. So for producing 1 unit we need 2 hours. For producing x1 unit we need 2x1 hours. So 2x1 hours that you need. So 2x1 hours by a skilled man is required for deluxe model only. Now let's see the ordinary model. We are only considering the skilled man right now. The ordinary model requires 1 hour work by a skilled man. So for a single unit of ordinary model you need 1 hour work by a skilled man. So how many units of ordinary model that you are making? X2. So what is the total amount of time that will be required for producing x2 unit of ordinary model? So for 1 unit of ordinary model it requires 1 hour work by a skilled man. So for x2 unit you need x2 hours by a skilled man. So this is the total amount of time that should be given by the skilled man. What is that? 2x1 plus x2. Total amount of time that should be given by skilled men, 2x1 plus x2 is the total amount of time that should be given by skilled men to produce x1 units of deluxe model and x2 units of ordinary model. Now similarly, if you consider, now we have considered the skilled men criteria. Now we will talk about the semi-skilled men. Again, for 1 unit of deluxe model it requires 2 hours work by a semi-skilled man. For 1 unit of deluxe model requires 2 hours work by a semi-skilled man. So for x1 unit of deluxe model you will require 2x1 unit, 2x1 hours by a semi-skilled man. So for 1 unit of ordinary model you need 2 hours work by a semi-skilled man. So for x2 units that you are producing, so you need 2x2 hours, 2x1 x1 is the number of units that we are producing. We are considering deluxe model, so I got confused, I'm sorry. For a deluxe model it requires 2 hours work by a semi-skilled man. So for 1 unit you need 2 hours work by semi-skilled man. For x1 unit of deluxe model you will need 2x1 hours for a semi-skilled man. Okay, now similarly for an ordinary model you need 3 hours work by a semi-skilled man. Okay, so for 1 unit of ordinary model you need 3 hours work by a semi-skilled man. Now for x2 units of ordinary model you need 3x2 hours for semi-skilled man. So we have got the total amount of time that should be given by a skilled man and semi-skilled man to produce x1 and x2 units of deluxe model and ordinary model respectively. So what is the total amount of time that should be given by a skilled man? It is 2x1 plus x2 hours. And what is the total amount of time that should be given by a semi-skilled man? It will be 2x1 plus 3x2. Now associate these two with the constraints. This time, whatever be this time, it should be less than or equals to 40 hours. Why? Because that is the total, that is the maximum amount of time you are having in a particular day by skilled men. You cannot go beyond that. You can have less than 40 hours. You can have equals to 40 hours, but you cannot have greater than 40 hours in a day. And this is the total amount of time that is needed by a skilled man to produce x1 and x2 units of deluxe and ordinary model. Okay, we don't know the values for x1 and x2. Whatever be the values for x1 and x2, this much time should be less than equals to 40 hours. Similarly, for the semi-skilled man, the maximum amount of time that you have in a day is 80 hours. This is the amount of time in a day that should be given to produce deluxe model and ordinary model. Okay, so this amount of time can be equals to 80, but it cannot go beyond 80. So less than equals to 80. It may be less than 80, but it cannot go beyond 80. It may be less than 80 or it may be equals to 80. So these are the two constraints that we have. Now we are ready to, this is the rough work that we have done. Now after doing this, we have to express the problem in a proper way, in a standard way. So this is the standard way I already have discussed. Okay, so first write the LPP is formulated as follows. So first you write the objective function, maximize. This is our objective function. We already have formulated. Maximize z equals to 10x1 plus 8x2. Your objective is always subject to the constraints. So you write subject to the constraints. Now write the constraint. What is the first constraint? 2x1 plus x2 less than equals to 40. The second constraint is 2x1 plus 3x2 less than equals to 80. The first constraint is related to your skilled men. You don't have to write this, but let me write it for your convenience. The second constraint is related to your semi-skilled men. Okay, and the last but not the least, you also have to add the non-negativity constraint. See, the number of units for a particular product, it cannot be negative. So from that consideration, you also have to add the non-negativity constraint here. So how many decision variables you have? How the non-negativity constraints are added? See the standard form. Objective function subject to the constraints. After that, this is your non-negativity constraint. So how the non-negativity constraint looks like? The number of decision variables separated by comma greater than equals to 0. From the consideration that it can be 0, but it cannot be negative. So you write how many decision variables you have, x1 and x2. So you write x1 comma x2 greater than equals to 0. So this is your formulated LPP in a standard form. Okay, so that's all for today. And if you like my lecture, please subscribe my channel and hit the like button. Thank you. See you again.